All right, so let's see what should be reminded. Your programming test number 1 has been released, not just the marks, but also the feedback file. I included the detailed instruction in my e-class announcement. Please check them. And also, I made your original submission during the test also available to you. You just have to click on the link on the web submit and choose the right test version. You can also download your original submission. I would recommend, now that it's available to you, try to redo the test if you didn't do so well in the first trial. Maybe that can be also nice practice for you. And also, I made available the grading test that we use to assess your work. You can also use it maybe after you have redone the work. All right, so that's really resources to you. Try to make the best use of it. And your programming test number 2 will be tomorrow. And during your enroll lab session, make sure you come in time. And then we'll start in time as well. And your lab number 3 will be due this Friday, right? Just remember, this is a simpler lab. It will take shorter amount of time. But in the future lab number 4 and 5, it will be given, again, 2 weeks. But for this one here, just shorter than usual. Please note the deadline. And again, if you really cannot finish everything, just submit your best attempt to claim the credits. And I'll release a solution to you, also to make it available for you to study. All right, any question about the course in general? All right, so today we should really start, finish the final bits of the example about equals method, and then we should really start a new topic before inheritance. Maybe not today, but definitely on Thursday. Okay? So let's do a quick recap about what we discussed on last Thursday. Okay. So last Thursday was mainly about short circuit evaluation. Even though it's a logical operator that you know how to use programmatically back in the first year, but to really be sure that you understand the short circuit evaluation is also very important because we might use it inside the equals method or in other contexts as well. It is very important for you to know, number 1, the truth table for AND and also OR. And also understand about what exactly is a short circuit evaluation, meaning that evaluation is going to go from left to right. There will be some special circumstances where you might skip the evaluation on the right-hand side of the operator. That's a very quick recap. But you should really refer to the details in the lecture if you got any doubts, right? And I assign, before that, also we talk about in the case of the conjunction, ampersand, the expression number 1 is more like a guarding condition for protecting the expression on the right-hand side. On the other hand, when you're doing a disjunction, or it's more like an error condition, meaning that if the error condition is really true, then you skip the right-hand side, right? That's kind of the thing we also spoke about last Thursday. Just make sure you read them, study them. And I also gave you some exercises over here. Should be rather straightforward to complete. But if you got any doubts about the answer, you can let me know. And we spoke about how things might go wrong if you simply do short circuit evaluation, but in the wrong order, right? So in the test or in your actual lab when you're doing programming, you want to make sure whenever you're using the AND or OR operator, the order of the operands really matter. And we started talking about more example about equals method, right? So 1, 2, and 3 over here, right? So maybe I don't need to repeat them, but you really got to review them. So in the test or in the exam, you might be given, of course, arbitrary classes. May not be point number 1, point number 2 anymore, right? You might be given classes where you have to be sure where the overridden method for equals is. If there's no such thing, you should always use the object equal. The principles still apply, but you will just be given new problems in the test. So you want to make sure you understand the principles and the example pretty well. And we spoke about how to use the short circuit evaluation by combining 2 conditions in the equals method, right? So make sure you also understand what the flow was like for that example. And we started talking about another more complicated class called person collector. So this is where I would like to pick up from Thursday. All right, before I do that, any question from last time? Any question about short circuit evaluation or other example that we talked about? Right, quite a bit of stuff, but you want to make sure you also keep reviewing. That's going to be good for your ultimate exam as well. Let's now go back to this person collector class, which I want to finish, about tracing it. Maybe it's not into 100% detail, but there will be some subtleties you want to pay attention to. It's really important to really learn from there. All right, very recap about how the person collector class will look like. Okay? Before that, we already talked about person class, right? And we talk about for expression like this, how do you know which version of the equals method that's going to be called? We also talk about analyzing such data notation, right? Also make sure you can do it. In the actual lab, in the test, you might be given something even longer, even more dots. But the principle of analyzing which version of equal should be called will be just the same. You just got to start from the left all the way to the right. Okay. Alrighty. All right, let's now go back to this person collector class. Okay. So we got a person collector here. We got persons array. We got some counter. So these are the only two attributes we have for the person collector, meaning that these are the only two things you may want to compare two person collectors. So that's what the equals method is going to be defined somehow. But we'll see. And we got constructor, we got mutator, we got accessor, etc. They are standard, right? And let's now take a look at how we overwrite the equals method over here, right? So we got these two lines. They are just standard, right? I don't need to repeat. And also, we got some casting over here. We also spoke about quite exhaustively, well, quite thoroughly, before, even before last Thursday. So how do you understand the cast? You can refer to the example earlier. What we have over here is we have a Boolean Boolean variable called equal. And then eventually, we're going to return equal, which might be true or false. Okay? Again, I would discourage you to really use any continue or break statements in Java. It's not a very good practice. For small scale example, they might be okay. But once you talk about software projects in large scale, using continue or break is going to cause some maintenance issue for your project. It's not worth your risk. Okay? All right, so what we do is we first of all consider if the number of persons in two person collector are the same. If they are not the same, that means we simply return the equal default value, which will be false. Right? If the two collectors store different numbers of persons, of course they are not equal, right? Maybe one stores 5 persons, the other one stores 4 persons. There's no way they're equal. If the number of persons they store in the collection are equal, in that way we're going to continue using a loop to compare, basically one by one. Right? So let's see here. So for example, let's say, let me show you some diagram very quickly. At the runtime, you got two person collector objects. Let's say you do have some person at each index. If their NOP are the same, let's say, what you would do is you're going to compare the person that's stored in index 0, and also person at index 1 and index 1. If the persons you're looking at the current index are the same, you go ahead and continue comparing the next person in the array. As soon as you hit the very first index where the two persons stored in the two collectors are different, in that way you know that it's now time to return false for the equal. All right, so that's kind of the general idea. And you will do something very similar, maybe for your lab number 3 as well. Okay? And of course, we got to do some tracing just to make sure you're feeling more comfortable about running this code. Right, so if you look at the code structure, nothing else to say. You just want to make sure you understand why the equal can be part of the conjunction here, right? So remember in the for loop, the middle part tells you as long as this part here evaluates to true, you're going to stay for more iterations. As soon as this equal here becomes false, how can it become false? Equal is going to be reassigned to, we try to compare the person at index I and another person at index I from the two collectors. As soon as we find that they are not equal, then we're going to set equal to be false. In that way, once equal becomes false, you're going to make this conjunction here false. So we exit from the loop. So once you exit from the loop, you're going to return the false for the equal. Right, so these are the different scenarios we might run into when we do tracing. But it's always good to kind of sketch a little bit in your mind to see how things might occur. So we'll see. Yes? Mm-hmm.
Let's say their NLP is equal,
Mm-hmm.
and the elements in both objects are equal. However, let's say for object 2, the index for the elements are different from the index in object 1.
Okay.
Essentially, they're still the same.
It really depends on how you define the equals. Of course, there might be multiple ways you can define that. But for our purpose over here, we do a very simple way. We say the following. So number one, we first check to see whether the number of persons are the same. If they are not the same, they are not equal. If they are the same, we're going to look at the contents of the two arrays over here. The way we look at that is by looking at pairwise persons stored at the same index from the two collectors. So index 0, we don't really compare, for example, index 0, index 1. We don't do that. That would be too complicated for this example here. Although, in some occasion, you may want to say, somehow, I don't want to care about the order. If I somehow got person 1 in one collector, as long as person 1 is equal to some objects in the other collector, in that case, you might need a nested loop. But that's too complicated for now. That's something for you to work out maybe in the lab later. All right? Right, so guys, the main message over here is this. How I define the equals for the person collector in some way is really for illustration purpose in the class. So I make it a little bit naive, but easy to understand so you get an idea. Realistically, you may not necessarily want to compare persons in the same index. You may want to be more flexible, but it's really up to your definition. Okay. All right. Okay, we're going to do some tracing. That's important. All right, so that's about the equals method. Any other question just about the code itself? Not very long, but I think it's important for you to especially see how you can use a Boolean flag, we call variable here. All right, and just to remind you, we also got another class called person, which we also spoke about last Thursday. The person class also got their own version of the equals, which will compare the weights, height, first name, and last name. Right? So we might need to use this as well. Okay, let's now try to trace. I got 1, 2, 3, 4. 4 different scenarios for us to go over. But they are not too bad. Let's start with some simple one. So let's say we want to create 4 persons, P1, P2, P3, P4. All right? And for P1 here, it's going to be first name A, last name A. Let me just be sure about, I believe his first name A, last name. Okay, let's say that's the case. Okay, first name, last name, and then the weight, 180. The height will be 1.8, right? And person number 2, similarly, A, 180, 1.8. Different objects, but the same contents. P3 is B, 200, 2.1, right? I'm just following exactly what's being passed to the constructor. And P4 here, no new objects. What we do is we simply say P4 is assigned to P3. Okay? And some simple comparison. P1 equals P2 should be false. They are different objects. And if I try P1 dot equals P2, right? So now the only thing we want to know is which version of equals is going to call. In this case, P1 dynamically is pointing to person. So we know the person equal is going to be called. In that way, we are comparing P1 and P2, and we are going to pass these two lines for sure. That's something you can convince yourself, right? They're the same dynamic type. And also OBJ, in this case, P2 is not equal to null. So we are fine. And when we get to this point over here, we're going to compare their first name, their last name, their weights, and also their heights, right? They're all equal. In this case, the return is going to give you true. Okay? And then when we try to do, let's say P3 equals P4. P3 and P4, they are the same objects. Of course, equal is going to give you true. And then we try to do P3 dot equals P4, right? Now, P3 dynamically is pointing to person. So that's why the equals here should be, again, this version over here, right? From the person class. And then we're going to compare basically the same objects. And you can see this right away. If this equals OBJ, so P3 is the this. And P4 is the OBJ, basically, right? So they are the same objects. In that way, we're just going to return true right away. right? Also easy to trace. And of course, important to notice, if you look at this line here and also this line over here, okay? It turns out the equals over here is being called for the same version, just the equals over here in both cases. This one here is going to give you true, but it's because this part here returned true. They are the same objects, but they are different objects, but the same contents. On the other hand, the second one over here, when we compare P3 and P4, again, we're calling the same version of equals, but a different line over here that returns the true, not this part anymore. Right? That's something for you to notice. Right? Any question about the scenario number 1, which is not too bad. We haven't even touched the person collector yet, but we will. Right, the example is going to build up. So if you download the source code I made available to you, you will see all the JUnit test cases there. So you can play with them, again, using debugger on Eclipse, and feel free to verify for you to modify them and make your own example. Okay, number 2. Let's now put person collector into play. We got PC1 and we got PC2. You can see PC1 here is going to just standard constructor. So that's why I don't really trace from scratch. So the person collector object has NOP and persons. And NOP initially is 0, and then let's say the maximum capacity is 100, let's say. So you can see the array here has been created, and every slot in the array is null. And notice that we got 2 separate arrays. One belongs to PC1, the other one belongs to PC2, because the attribute here, by the way, is non-static. All right, I'm also trying to review a little bit what we spoke about earlier. And first of all, let's try PC1 equals PC2. That one should be false, because they're different objects. All right? That one should be very easy to see, so this one here should be false. What about PC1 dot equals PC2? This one's interesting. All right, very interesting. PC1, first of all, dynamically is pointing to person collector. So I'm going to just make some color annotation for you. If you look at PC1, the context objects, dynamically PC1 is pointing to person collector. So that's why you're going to call this version of the equals from person collector. Okay? The same decision making that we spoke about. And question for you. At this point, you can see there's no person stored in either of the array. NOP here and NOP here is actually both 0. I want you guys to really take a look. I'll make this one a little bit bigger. Right? Just remember this diagram here, right? So 0, 0, and also the same length of the array where every slot is null. But if I try to call PC1 dot equals PC2, exactly which line are we going to execute, right? Why don't you guys take just 1 minute to think about? This one is a little bit trickier, but it turns out it's actually quite simple. Right? That's my question. Number 1, should it return true or false? Number 2, exactly which lines are going to be executed? PC1 dot equals PC2. Okay, just take 1 minute. All right, 30 seconds. All right, 10 more seconds, and then we can see if you got any thoughts to share. If no, I will share some thoughts with you. Alrighty, any idea? Number 1, should it return true or false? These 2 person collector. At the moment, they have no person collectors in either. Should it return true or false? Anybody? True, I agree. And follow up, right, which is more important. If it's going to return true, which line exactly are we getting the true from? Are we getting return true from here? Cannot be, because TC1, PC2, they are not the same object, so it cannot be this line. Okay? And also, PC2, the OBJ here, is not null. And also, they are dynamically the same object, person collector, person collector. So this one here and this one here, they are not going to be executed. So that means this part here is going to be bypassed. This one here also is going to be bypassed, right? I'm tracing this line specifically. And we're going to do some casting, right? And then we're going to execute this part of the code. And then we're going to initialize the equal to be false. That's good. And NOP, 0, 0. True. That means we're going to go ahead to execute this part further. All right? And as soon as we get to this if branch, we're going to reassign equal to be true. So at the moment, equal has been reassigned to true because we have a chance to get the two things equal. Now, here we are more focused. Guys, question for you. Look at the header of the loop. What's going to happen when we run the header of the loop for the very first time? Are we even going to go into the loop? No. Jennifer, why not?
Because the number of persons is 0.
0, and then somehow 0 less than 0 would be? So the line you want to really look at is this line over here. All right? This line here, we know that over here, this is the context object. In this case, this is PC1. Right? So we got PC1.NOP, which is referring to this value over here. Right? In the beginning, it is 0. And the loop counter initialized to be 0. So we got both 0. So 0 less than 0 is going to give you false. What does that mean? There is no person from PC1 to compare against. Nothing. All right? And we know that both arrays are both person collectors store the same number of persons. So that means at the moment, they simply store none in both arrays. In that way, we just don't need to compare. So this way, we don't even need to run any iteration. Just return true. Right? So that's a critical point for you to see. Right? I'm going to write it down here, just quickly. So here, because I less than this NOP evaluate to false right away, no iteration, run. And then we're simply just going to return the value for the equal, which corresponds to the true that we set it to be. All right, so this initial case here is pretty simple, but it's a little bit subtle. You want to know exactly how it's returning true. You see, because we simply have no persons to compare with, all right? Which makes sense. Conceptually, if you got two person collector, both of them are empty. In that way, they should be considered as equal. All right. All right, any question about this scenario here? So in the latest scenario, we're going to see non-empty cases to see what if, let's say, the two person collectors store maybe the same number of persons, but somehow the person may or may not be equal, or they simply store unequal number of persons. Right? So these are the cases we want to see as well. All right, any question about scenario number 2? Really make sure you understand this one here. That's really critical. All right, number 3. What we do is, well, we still got a person and person collector here, just for reference. And now we're going to add in P1, P2, P3, and P4 that we had from scenario number 1. Right? Okay, let's take a look. Let's now just walk through what's going to happen before we trace it. We're going to add one person, P1, into PC1. And then we're going to compare the two collectors right away. And then we're going to add another person to PC2, and then we're going to compare if they are equal. And then we're going to add another two persons into the collector and then compare them again. Right? That's kind of the pattern we're trying. So you really want to be sure up to which point do you have which diagram state. Right? It's important to really update your diagram as you're going. Okay, number 1. let's see over here. If I say PC1.addPerson P1, so PC1 is here, and if you want to add a person to it, we know pretty well how to do this. So now PC1, rather than pointing to now at index 0, so now it is going to point to P1. And then update NOP to be 1. All right, very simple line. And that corresponds to what we have learned for so many times about the programming pattern. And let's now try to do PC1 dot equals PC2 right away. All right? And because PC1 dynamically is a person collector, so we call this version of the equals in person collector, which is here. Okay, I'm going to save the time a bit to tell you. What's going to happen is, dynamically, these two are of the same types. Person collector and also person collector. Somehow I missed it in the title, but it's person collector. However, you can see the NOP here, they are not the same. So this is where we're going to return false for this equals call, right? Because NOP and NOP here, they're not the same. So this is exactly where we're going to get the problem. Okay, so here, this is the line where okay, so let me just write it down here. At this point, PC1 dot NOP at the moment is 1. Is 1. And also PC2 dot NOP is actually 0. So they are not the same. So we're simply just going to return the equals initial value, which is false. Right? So the very first comparison is going to return false. Any question about this? We're comparing two collectors with different length, with different numbers in the collection. And the next one here, we're going to just add another person, PC2. Okay? P2, add P2 into PC2, basically. Right? So that one there, PC2 here, and then we're going to add, so this part here, rather than pointing to null, so now we're going to say P2 is going to be added. So that's what we do. All right? And then we're going to update NOP to be 1. So now you can see if we run the equals again, we wouldn't actually just reject them right away because they are unequal number of persons stored. Right now they are equal. You can see now NOP for this one is 1. NOP for this one is 1. So we are not going to return false just because this one fell. Not anymore. All right? That's the subtlety you want to notice. But what's going to happen? If we go in there, over here, what's going to happen is we're going to run the loop because now we have non-empty case. What's going to happen is when we execute this loop over here, let me just write it the first time. So I will be 0, so that means this dot persons at index 0 for the very first iteration dot equals and then other dot persons at index 0, right? I is currently 0 for the very first iteration. And that we know that since we are calling this, so this will be PC2. Other will be P2. So this is PC2, beg your pardon. That's PC2. And other here is PC1. And we are basically comparing the person stored at index 0, which is here, and also the person stored at index 0, which is over here. And now the way to compare these two person objects, you can see they are different objects. If you simply compare their references, we're going to fail. But we are calling the equals method from the person class. This is important. In the person collector class equals, we are calling the in the person collector. Right there. So the equals method here comes from the person. So what I really meant to say was, when we are trying to override the equals method in person collector, we are making use of the equals method from the person class. This is very normal. Within the equals method of one class, you may call the equals method from another class. That's what we're seeing here. All right? And if you compare this person here and this person here, you can see content-wise, A, AA, 181.8, 181.8, the same. So that's why this line over here is going to give you true. So if you try to execute this line over here, it's going to give you true, right? It's going to be true because PC1, let me write this down. It's true because I'll put star here, and you can refer to this part over here, right? It's reading that first iteration we're calling. We go to the first index and the first index in the two-person collector, and then we found that the person here and the person here, they are equal as far as the definition of equals goes in the person class. All right. Okay, let's do two more persons. Okay. And what we do is we want to add P3 and P4. You can see P3 and P4, they're really referring to the same objects over here. Right? So what we do is we're going to say add P3 into PC1, add P4 into PC2. How the diagram should be updated, that's important to see. Okay, so let's see this. So how about these two lines? So P3 and P4. So P3 is pointing to here, so we're going to let PC1 at index 1 over here. So rather than pointing to null, it's now going to point to this object over here. All right? And also for PC2, index 1, rather than pointing to null, it's now going to point to this object over here. All right? So far, it seems like we are growing the PC1 and PC2 one by one. And the person we added to the corresponding index happened to be equal, which is okay. And finally, if you try to execute this line here, PC1 dot equals PC2, right? Similar idea. So what's going to happen is, because you can see we're going to compare index 0, referring to this person here, they are equal. And then when we get to index 1 over here, that one is referring to this person here, and that one there, oh, I just went to the wrong person. That's my bad. Let me just fix that. So what I did wrong was this line here. It should be P4. Okay, P4 here. So index 1 should be pointing to P4, which is the same objects. Okay, it's good I've spotted that. It's now fixed. Okay, so when we actually execute PC1 equals PC2, comparing index 0, which will be these two persons, they are equal. We know that. In the second iteration of this comparison here, we're going to look at index 1 and index 1. And they're both pointing to just the same objects. Now, with the same object, we know that person equal is also going to return true. Because over here, this is where we're going to see the return true. Okay? So if you think about this is star, star, star. And this is where star, star, star is going to return. So that will be true. I'm only trying to highlight exactly what you're supposed to pick up from the example. What you should really do is try to maybe trace the code yourself first, so you will really appreciate so many details over there. And then you can revisit part of the lecture and see the highlights I'm talking about. Okay? Any question? We got one more scenario, but before I move on, any question here? Don't lose the big picture. What we're doing here, I know there are many details here. It could be slightly confusing, but you just need to dive into details. The big picture goes like this. When you actually got two objects over here to compare for equal, individually, they have some array and array. How do you compare them? Unavoidably, you have to use a loop. And the naive way to compare would be, I simply go over this array and go over this array, which is what this loop is doing. I go over this array one by one. I go over this array one by one. And look at index 0. Is it equal to index 0 over here? If it is, I move on. Is this index 1 and index 1 equal to each other? Yes, it is. So I move on. Let's say, for example, if I get to index 2 and index 2, somehow they store persons which are not equal. In that way, I know that I should really set this equal Boolean variable here to be false, which is going to cause the loop to exit. In that way, I'm going to return false. So that's a big picture. All right? Okay, questions before the last scenario. All right, that's now the last one. The last one, basically, I'm going to add a fourth person, but that fourth person somehow is not the same. All right, that's the trick. So this diagram here already shows you where we have got so far. We got basically 2 persons in person collector 1. We also got 2 persons in person collector 2. So far, the persons P1, P2 are equal. And also this one here, and also this one here, they're also equal so far. That's what we did in scenario number 3. Let's do the final one. What we do is we say PC1, the add person, we got a new person here. And also PC2, add another new person. Notice that these 2 persons are not the same. The heights, for example, is not the same. You can see that right away, right? Okay. So what we do is we got a 2-person object over here, which I'm going to put here. Let's say the very first one. This one is A175, 1.75. And the second person will be A165, 1.55. Right? These are the 2 persons. And then when I do add person, the first one, so PC1, currently NOP is 2. So rather than pointing to null, it's now going to point to here. This new person here. All right? So that's a new one. And then when I say PC2, the add person, I'm going to add this person over here. So index 2, corresponding to this, rather than pointing to null, is now going to point to here. So it really boils down into comparing this person over here and also this person over here. They are at the same index that we just added. Okay? And the final code for you to really convince yourself is, what if we say PC1 dot equals PC2? Right? Let me tell you the highlights. What's going to happen is we know that PC1, the context object, is pointing to dynamically person collector. So again, we're going to talk about this equals method here. And then the critical thing is when we get to this for loop over here. At this point, this .NOP, this is PC1. PC1.NOP, oh, by the way, after adding this third person, it will be 3. Right? I just forgot the updates. This will be 3. So this .MLP will be 3. That means I is going to be 0, 1, and 2. So I is going to be 0, 1, and 2. When I is equal to 0, we're going to compare index 0 pointing to this object here, and index 0 pointing to this object over here, comparing these 2 persons using the equals in person. Right? That's iteration number 1. Iteration number 2, index 1 here, and also index 1 here, just the same object. That's what we did earlier. Now, iteration number 3. This is the critical one. Index 2 pointing to this person object here. Index 2 pointing to this person object here. If you look at these 2, are they equal? Not really, because you can see 175, 165. They are not the same. Okay? So the highlight here would be PC1 dot persons at index 2. And then when we say dot equals PC2 dot, I'll try to write it a little bit more legibly. And then I say PC2 dot persons at index 2, right? You can see I is now being used as 2. 2 and 2 here. And this is going to return false, because we got, for example, 175 and 165. So this one here is going to give us false. So that means ultimately equal here is going to be assigned to false. So ultimately we return false. So this equals here will be false. Right? Very, very important for you to trace. I try to do it in a fast-forward motion, so you don't really get too much or too lost into detail. But I'm just telling you, that should be the overall way to really trace the code, right? Which is important. If I give you maybe different classes, different equals method definition, you have to know how to trace, right? All right, any question? We're good? Alrighty. If you're good, so I would suggest, let's look at the slides. I believe that's the last example I would like to talk about for the equals set, but let's be sure. So we talk about the person equals, and then we had a discussion last time, and also we got person collectors, right? So this is the JUnit test case I kind of described in different scenarios, kind of broke it down, right? So when you do the exercises, maybe take this JUnit test and put a breakpoint in the first line and try to trace line by line. That'll be the way to understand the best. All right. So that'll be it. Yeah, play with the source code made available to you. That will be the best way to grasp runtime behavior. Question? All right. So let's now move on to a new topic. I would suggest we spend maybe the next 10 to 15 minutes on the call by value. It's not that difficult, but I just need to make sure I do the example together with you, and then we take a short break afterwards. Okay, we'll see how that goes. If that goes too long, I'll take a break first. And the slides is already on your lecture site, so let's now start with this one. And this one can also potentially help your understanding about equals method a little bit. Okay, we'll see. Aggregation composition, but just for your information for today, in the last 10 to 15 minutes, I would like to start with the composition first. Aggregation is just a fancy name. That's basically what we have been doing so far, just with aliasing possibility. But for composition, it will be something a little bit different. That's something we're going to talk about. All right? Let's talk about call by value first. All right, call by value and also aggregation composition. And these two I will save for some quick discussion on Thursday. They are not that new. But for this one here, I'd like to start with that first, copy constructor, which is not difficult. Okay, call by value first. Let's go over some slides. And in order to really understand call by value, you have to be very clear which is the parameter and which side is the argument. And also which side is the caller and which side is the callee. And fortunately, we have talked about them all so far, right? So whenever you have a method call like this, now the argument here potentially can be either a primitive type or reference type. So this is where the call by value comes in. It makes a difference depending on the type of the argument. I'll give you an example in just one moment. This is important. Now this is very technical. Somehow the argument here, whenever we are calling some method m with argument somehow is made a copy before you can call the method. That's really what this line is saying, but we're going to visualize it. And depending on the type of the argument, the copy is going to be a little bit different. The consequence can be slightly different, right? But you can go over the slides, but I'll rather just do an example right away to see exactly how things will work. All right, let's now clarify some terminology very quickly. All right, so if you recall, we actually said, so here we are calling a method here. So when we call this method over here, right, you can see m is being called. M is from class, the context object CO, which is declared to be class A. So in this case, we know that A.m is the callee. Right? We learned about this when we talk about exception. This is still very important. And then we know that, so A.m, this is the callee. And the context where this method call is made is a caller. So you can see the B here, and also the N here. This is where the method is being called. So this is the caller. B.N. All right, caller, callee. And what's important now is when we are calling this method here, we're passing some value as the arguments. So this is some concrete value, arguments. And then we talk about in the callee side. When we declare the method, we got to give a name to this input. It's called parameter. Okay? So this one here is called a parameter. So this is more like a variable. Okay? Parameter. All right, nothing new so far. But now, let me add one more detail you should know for call by value. And I'm going to put it here. Here, we say that paren is a copy of arguments. If you look at these two together, I want you to look at these two things. This is where the M is being used, in which case, when we trace the code, we have to somehow know what param exactly is. What's happening in the runtime is param over here is exactly just a copy of the argument value, ARG. All right? So that's the principle. But let's use an example to illustrate. So param is over here, and also the argument is over here. And whenever you have a method call, always remember we are connecting the method call back to the definition of the method of the callee. All right? So that's why we got parameter versus argument. Okay? This is just to clarify terminology. And this is the new bit you want to know. All right? Let's see exactly how we can visualize that in the example. Okay, let's start with something simple. Okay. Let's say over here, we got circle user, circle first. So this is going to be the callee, because in the circle class, we got radius, and also we got set radius. And for the set radius, we are taking some integer. Right, so what you want to know is this parameter here is primitive. So this R over here is a parameter, but it's primitive. Primitive parameter. And it does something very simple. Just set the radius to be R. And what's going to happen is in the circle user, which is a caller, we're creating a circle objects, and then we are passing some argument of type of value 10. And you can see the argument here is also a primitive. Right? So this is a primitive arguments. All right, let's now trace the code to see exactly what I mean. That param is actually a copy of arg. So what do I mean by that? Let's now try to trace the code line by line. Start from here. So we have C pointing to some circle objects. So circle objects, and every circle has just one attribute, radius. I'll say R over here. Right? Initially, it was simply just 0, default value. And then we have some argument just called arg. You could call it anything you like. This one here is simply a variable primitive, so it's like a box. So arg is 10. So far, so good. And we are calling this method here, c.setRadius arg. Now, this is where you got to pay 100% attention. All right? When you call this method here, as I said, we want to make a connection to where the method is defined, which is over here. Okay? And then I'm going to highlight this declaration here, right, which is here. Now, how exactly are we going to visualize R? R itself, first of all, is integer. R itself is actually an integer. And then call by value tells you when you try to make a method call here, R is a copy of arg. So R is the parameter here, and arc is the argument over here. So now, which is 10. So now make a copy of 10 and put it here. Separate copies. What does that mean? That means inside this method over here, if you try to modify the value R, is it going to impact the original arc? Not really. They're separate boxes. That's important. All right? And then, of course, now if you say this, the radius R, and now notice that the R here is really referring to this 10. The original 10 here that's being copied is no longer our focus. It's just being made a copy of already. So this is what's happening when the argument and parameter happen to be primitive. All right? That's a question. Any question? Of course, the tricky bit would be when we get to the point where the argument and parameters are actually reference type. In that way, things will just slightly more complicated, but we just have to know how to deal with them. Okay, let's now consider the reference case. Still, we got circle. We got circle here, we got radius, we got constructor, and also we have a circle that can be created with some radius, right? Just overridden constructor. Sorry, overloaded constructor. That's what I meant to say. And we got set radius over here, and notice that here, the set radius has taken circle rather than just integer, right? You can see now we changed the parameter type. So this is a reference type parameter. And this one here, you can see argument is actually a circle, which is also reference type. This is reference type arguments. And if you recall what we just learned, if you look at this method call here, set radius is being connected to the callee over here. If we try to connect them together over here, and let me just write down the principle that applies to both primitive type and reference type. So here we should want to say C, the parameter, is a copy of the arguments, which is over here. So what does it really mean when I say C is a copy of arc? Copy of arc's value. Well, what's arc's value? Arc is a reference type. Address. We're copying address only. We're not copying the entire objects. Right? Let's see exactly what's happening here. Let's now copy, and let me just say one more thing. Copy of the address. This is very critical. So the principle would be the same between primitive and reference types. However, when we say copy the value, when you copy the value of a primitive value, it's just a value. But when you copy the value of a reference variable, it's copying the address of the objects. Right? It's slightly different interpretation. All right, let's now trace the code. So we got circle C over here. So C is pointing to a circle object over here with radius, default value, 0. Radius and 0. And then we got arguments, which is just another circle objects. Okay. Let me use maybe green. Maybe purple is fine. All right, so we got arc, which is just another circle object over here, just different. And circle. And this time we're taking some argument. You can see that's exactly this one here, right? That one's easy to see. So now we got a radius over here, 10. So far we got C and arc, different objects. All right? And how do we understand this method call over here? We're calling set radius by passing arc. So when we try to trace the code in here, circle C, C is a parameter. C is going to be a copy of arc, which is over here. We're creating an alias. not a new object. So what's happening here is the C here is simply going to be called pointing to arc over here. That's what's happening here. Another way you can understand is like this. When I say C is a copy of, it will be as if we say C is assigned to arc. You don't really do this variable assignment yourself, but that's behind the scene. Okay, let me repeat again. When you are making this method call over here, by passing argument value arc, the corresponding parameter is going to get a copy of arc by executing this implicit assignment, which was not written by yourself. It's executed by Java runtime. So when I say C is assigned to arc, we know pretty well what that really means. That means C is now going to point to wherever arc is pointing to, corresponding to what we learned earlier. So the only new thing we're learning now is whenever you're making a method call, just remember the parameter C is assigned to the argument, whatever value it is. Symmetrically, so what I said over here, I can also add it. When we get to the primitive value case, so if you look at R is a copy of arc. So this one, it will be as if. I say R is assigned to arc. So this is to say R here is really assigned to the value of arc. Because they're primitive, just copy the value of 10 over here. Right? Similar idea. So the same variable assignments, parameter is assigned to arguments. But depending on the type of the arguments and parameter, the consequence will be slightly different. Okay? Any question here? We haven't really manipulated callback value just yet. I'm just showing to you the definition to see how exactly we can visualize the callback value in the primitive case and also in the reference case. All right. Any question here? Question?
So if you were to modify C.
If you talk about modification, that's good thought. That's exactly what I'm going to talk about. How about this? Let me look ahead a bit. The primitive case is not that exciting, but we're going to do one example anyway. But let's talk about the callback value for reference type. So let's say within the context of this method here, we know that C is a copy of arc. So this is what we have right now. There are two possible changes we can make to C. Number one, if we say C is reassigned to something else, diagrammatically, is it going to modify arc? Not really. If you simply say C is now reassigned to something else, we are not really modifying arc. On the other hand, if we say we're going to call a mutator on C, so C, the circle, dot, let's say, increment the radius. In that way, we are really modifying the same object over here, maybe from 10 to 15. And the effects is also visible to arc. So there are two possible changes for the reference type callback value. That's something we're going to study a little bit further. But I basically just summarized the essence of what we're going to see. Okay, let's see two more examples. Let's now start with something simpler, just the primitive type. So let's say we have a class called here utility. And then we have some method here. We just want to reassign the integer parameter j. Right? Excuse me. We got integer parameter. And we simply say, whatever parameter I'm getting, I'm just going to increment it. All right? Let's now look at the code. I have some utility object here, u, which is simply just utility. And in this case, utility doesn't really have any attribute, let's say. So we don't, join the box is okay. And then we say integer I here is 10. All right? And then we just make sure I is the value 10, which is good. And now this is important. when we try to make this method call over here, and then it's corresponding to this method call over here. Agree? Call by value tells us that we have to somehow connect them together. And the way to connect them is like this. So this one here, call by value, tells you J, the parameter, is simply a copy of the argument I. That's the first thing you should do before you start tracing the method call. If you're having two method calls, you have two instances of call by value. Okay? And when we try to trace this code here, before that, we're going to make sure we visualize the J. J is simply a copy of I, which is 10. And then we say that J is incremented, 10 to 11. Now you can see very clearly, when we modify J, does it modify the argument here? No, it doesn't. So that's why after this method call, you actually try to assert again that I remains to be 10, which is true. So this might be some error you maybe tend to make, or some of your classmates tend to make back in the first year, which is when you try to pass maybe some value over here, you say, I will expect this particular method to increment I. It's not possible, as I illustrated to you, because the I here is always stay here. And the method call you're calling here always make a separate copy of the I. So no matter what you do in here, you're always doing to the copy. You're not doing that to the original I over here. Right? So that's why you want to see this one remains untouched. So here we want to say arguments stays untouched. All right, that's important. All right, any question here? All right. If no, let's now move on to reference type for call by value. Okay. Before that, why don't we take a very short break, and then we'll take attendance, and we'll do that one right after break. Alrighty, so before the break, we talked about call by value definition, and we went through the example of the utility using primitive. Now, let's focus more on reference type. I think these two examples, a little bit, the names are a little bit contrived, a little bit abstract, but I really illustrate what's happening for call by value for reference type. So there are two scenarios to talk about. All right, let's now take a look. And number one, I want you to take a look at this method here. So this one here to say I want to reassign the reference, right? The method name itself suggests what it wants to do, okay? I got some point, let's say point. Don't worry about point v1, point v2, that's not the point, just a point, okay? I got some point parameter q. And then inside, I say I want to create a local variable np, new point. And then I want to reassign q into np. That's exactly what it is trying to do, right? Reassign the parameter reference. And what we want to do is we want to run this particular test to see what's going to happen if we execute this method, right? Are we able to, for example, when you try to say u dot reassign reference, which is calling this method here. Now p, the arguments, somehow is going to be copied to q, somehow. Now, if we try to reassign q to be something else, are we changing p at the same time? That's the question. The answer should be no, but we're going to see how. Okay? And for your reference, this is just a point with x and y, right? That's pretty straightforward. Let's now execute the code. So we do line here. So we got u, which is utility over here. No attributes. And then we got point p. So p is pointing to some point objects with x and y. And we got 3 and 4. X and y, 3 and 4. Okay? And then we got another variable here. So this is actually for testing purpose, but let me put it. So I got another variable here, reference of p before. So reference of p before. It's just pointing to p here. Okay, just here. right? And then we are making a method called reassign ref, which is referring to this method here. Okay, this method calls. And we are trying to here connect these two things. And the way to connect is call by value. Call by value, by definition, the parameter Q is assigned to the argument P. Right? That's the most important definition you have to know. Okay, Q is assigned to P. What does it do? What it does is it's going to create it's going to create Q over here, and then it's going to point to wherever P is pointing to. So this is call by value in the case of reference type. We're just making the same address as the arguments. So P here, as you can see, is the arguments. Just make a note here for you, it's the arguments. On the other hand, the Q here is the parameter. And the way we connect them together is by using this implicit assignments for variables. And then when we trace the code here, let's say here, what we do is we got some new point. So MP is pointing to another point over here. That one, 6, 8. So we got X and Y, 6 and 8. And then finally, we say Q is assigned to MP. Right? So Q, the parameter, rather than pointing to here, is now going to point to MP. Now, it is important to note, when we are modifying the Q by reassigning that to something else, does it modify where P, the argument, is pointing to? It does not, because they are separate addresses. Sorry, they are separate copies of the same address. So when you simply say Q, rather than storing this address, you want to store the address of another object. It doesn't really impact what's being stored over here. All right? So that's why afterwards, when you try to say P is still the same as reference of before, they're the same objects. Right? So you haven't really modified the P. All right? And similarly, if you try to also check to see what's P dot get X, P dot get Y, is still 3 and 4. So the same. So this will be the simpler case where in some way, if you're ever trying to do this in your Java code to say, which is to say, I want to reassign the parameter object into something else. That means you're not really understanding what's going on. Because whatever you do over here to reassign the Q, you're not doing anything to the argument over here. No, they're separate copies. All right. Now think about this example here. So let me write down one more remark for you. It's never possible to reassign arguments P using a method call. Because of call by value. If you want to reassign P, what would you do? You reassign it by saying P should be assigned to something else in the same method. Okay, one more example here. Now, pretty much the same stuff, but let's now try to see, is there anything we can do slightly to really modify the argument object? It is possible to some extent, which you cannot do for primitive value because there's no objects in the primitive case. So what we have is we have this method here, change by reference. So we still got a point, reference type parameter, and now we say Q here, rather than saying Q is reassigned to something else. We don't do that anymore. What we do is we try to call some mutator method on Q, which effectively is going to modify the contents of the objects. And these changes will be visible by the arguments, but we're going to see exactly how. All right, let's now trace the code once more, and then that'll be it for the example. Okay, we still got utility, and this time, let me now draw the utility box. It's not really being used. Let's say this one here. So we got P, the point, is basically point objects 3 and 4. And P is going to be used as arguments. So 3 and 4. And also to really double check, we also make sure we know reference of P before. And just pointing to the same objects. We want to make sure there's no reassignments of P possible by using a method call. All right, let's now call this method here, which corresponds to this guy here. And again, always remember to draw some connection between them, which will be implicitly an assignment. Q, the parameter is assigned to the argument P. This is what's going to happen even before you trace the code. All right? So what we have is Q is pointing to the same object as P. So now we do have aliasing over here. And if you try to trace these two lines to start with, at the moment, in the very beginning of this method here, P, the arguments, Q, the parameter, they both point to the same objects, right? So what's going to happen is we're going to say Q dot move horizontally by 3 and move vertically by 4. So it's going to modify just this object here. Oh, I wrote something funny. 3 and 4 should be X and Y. Okay, let me just fix that quickly. X and Y. All right. So now if I say move horizontally by 3, so 3 is going to be incremented to 6. And then move vertically, so that we go from 4 to 8. You can see what's happening here. We are not really trying to do any reassignments over here. We say we're now going to modify the object that's being pointed to by Q. And by the way, that object is also being pointed to by the argument P, because called by value. Now, let's now switch back to the context over here. If you say, does P remain the same reference as before? Yes. P and this guy here still point to the same objects, though this one should pass. However, now you want to see that when I try to check to see P dot get X and P dot get Y, P dot get X, P dot get Y has been modified to 6 and 8. But in the case earlier, the 6 and 8 that we created is a local points that we try to reassign to Q. But that one doesn't help because Q itself is a copy of P. So that's why P remained to be 3, 4 in the previous case. But now in this case, we are able to modify P's contents to 6 and 8. So that's the highlight you want to convince yourself when you study that. Okay, so here, the contents of the objects pointed to by P were modified by this particular method here. Okay? Any question here? All right, maybe something new, but it's not too bad. I got 2 minutes. I want to do one more highlights, and then we can finish call by value today. Let's now revisit our equals method and see what's going on. So there was just one more detail I'd like to add to see we can make our tracing slightly better, slightly. Okay, so now I want you to look at this example here, which we traced before, but now I'm going to do something a little bit more detailed with call by value. Let's say we're creating P2 and P3, right? 2 of them. So 3, 4, 4, 5, 3, 4, and 4, 5. We got 2 points. And then how do we trace the equals over here? So you can see P2 dot equals P3 is calling a method, and the equals method here, that's the one we are calling, right? Call by value will still be applied. So the way to really connect these two, which we didn't say before, all right, this is important. Call by value is going to make sure we do the implicit assignment as follows. The parameter obj is assigned to the arguments P3. This is very important to see. That's an application of call by value. So what's happening here is we do have OBJ over here, right? The parameter, static type is objects. It's going to point to wherever P3 is pointing to. So now if you try to trace the code onwards, as we discussed earlier in the class, now whenever you talk about OBJ, it's simply just pointing to the same object as P3 is pointing to, just the same. That's called by value, pretty much the same as before. The only difference is, if you look at the static type, OBJ was declared to be static type objects. On the other hand, if you look at P3 over here, the static type is point v2. P3, the static type is point v2. So that's why, even though they are pointing to the same objects, but if you say obj.x, obj.y, we know that it wouldn't work. Right? That's what we said earlier. All right, that one just an aside to really make sure you understand how to trace the equals method using call by value. All right, it's a good point to stop over here, and then we're going to continue with aggregation composition. All right, thank you. I'll see you in the lab tomorrow.